Buddy Computer Smart here. I'm here to bring you another C tutorial, and we're going to be discussing linked lists and how to correctly create a linked list in C, and the method behind it and what it's doing and how the data structure actually works. So before we get into anything, I just want to include my headers. So hashtag include standard io.h and hashtag include again. We're going to do standard lib.h. Alright. So, a data structure in C, or a linked list in C, is a type of data structure in which it uses less contiguous memory than an array. It was more useful back, I would say, in the 80s, 90s, early 2000s, when RAM wasn't as we don't have as much excess of RAM than we do now. We have 16 gigabytes of RAM in a normal desktop nowadays, and 32 gigabytes is like a high average desktop RAM. So contiguous memory is becoming less and less of a problem. However, linked lists are still useful, as we use them for trees and graphs and certain algorithms where you can recursively traverse faster than you could in an array, or find or compare numbers, or sort structure. And sometimes it's faster in a linked list, or it's more viable in a linked list. So let's continue. So the first thing you want to do is you're going to be creating your type def structure. So you're going to be calling type def struct, and we're going to call it node. And inside that node, inside that structure, we're gonna have an integer value called val, and then we're also gonna have a struct node star pointer. So we're gonna call it next, and then we're gonna call this whole structure node. So this right here is gonna be our address. So the address to the next node in the struct. So as you traverse a list, this next variable is going to hold the address of your next node. The name is fitting, so hopefully you get that. So basically, if we have the first node holding a 1, this arrow signifies the next variable inside this this block of memory, or this structure right here, this node structure. So all the way from here to here, that's one block. It holds the integer value and then the address. So imagine this being an address of some sort pointing to another node. So let's say 2, and that points to 3, and that points to 4, blah blah blah, and so on and so forth. So now that we have that down, also you're gonna have this point to null. So this would be your first number you would have put in. I'm sorry. The null would be back here. However, the null will be back here, and you'd be traversing your list as time goes on. So the 4 would be the first number you would have put in, then the 3, then the 2, then the 1, and that just keeps getting pushed further back and back in the list. So there isn't a list where you push back. However, it has a little bit more traversing in it through each cycle, or through each insert. You have to traverse all the way to the end of the list, and then push to the back. You can avoid this by having a front and back pointer, but that's a lot of bookkeeping you do not want to do right now if this is your first linked list. So, what am I doing? No. Alright, we have to have something to push onto the stack. So we're going to call a void of return function called list push, and this is just going to push nodes. This is going to just be pushing values onto the list. So we're gonna have a variable node double star L, and we're also gonna have a variable holding the integer value we want to push. So we're gonna have a temp variable, or a temp node. That's gonna be a pointer temp, and that's what we're gonna call it. And this temp is gonna be equal to malloc, or we're gonna malloc allocate space for us. So we're gonna have it equal to malloc size of a struct that we up here, struct node that we defined up here, and that's gonna be the end of that line. And then we're gonna have a temp follow val, which basically takes the you're gonna be setting the value of the structure, that value in the structure. So temp val is gonna be equal to val that we have in this function the user inputted to us. Then temp point to follow next is going to be equal to star L, which is the previous node that was in front of us before. Then we're going to have star L is equal to temp. So then we're going to say the front of the list is now temp. So we're just saying this doesn't always hold the front of the list, and the front of the list is now the temp variable, the temp node that we just put on there. And then we just successfully pushed a node or a value in the stack on linked list. So before all this is done, we need to create a function in which it creates the list, or initialize it. So I'm going to list init, which means initialize. We're going to have a node double star L, and what we're basically going to do is we're just going to take star L is equal to null, and star L file next equals null, and star L file val is equal to some arbitrary number, -1. Alright. So this is just setting our list, so setting the null. So when we traverse our list, we know when we can stop. Okay, so we also need a void return function called list print that's gonna print out the list for us, so we don't have to do that in main every time. So we're gonna have a node star. It's gonna be, I'm gonna just call it L. Names are arbitrary. And in this, we're gonna have a temp, node star temp, so we can use that to traverse a list. And we're also gonna have a printf, and we're gonna print a bracket just for tidiness. And we're gonna say while temp does not equal null. Oh, also we need I forgot to initialize this, equal to star list. While temp does not equal null, we're gonna printf, and we're gonna say %d, which is an integer. I'm sorry, I feel like I'm gonna sneeze. Never mind. Sorry about that. Sorry about that, guys. Then we're gonna have a temp val. We're gonna print out the value that's in the current node in the variable val, and we're gonna end that with a semicolon. Go to the next line, and we're gonna say temp equals temp follow next, where we're basically saying we want the next variable in that linked list. So this is just grabbing, or better word, traversing the to the next node in the list. Perfect. Okay. And just for looks, I'm gonna print f, and I'm gonna end the bracket. That looks good. All right. let's have a new line character just in case we need to print something else. Too many lines actually. Alright, and now we're gonna have a list. We need to have a list free or something to free the list, because we don't want to be bothered with that in main. We just want something that we can always use. So we're gonna have a thing called list free, and it's gonna take in a node double star, call it L, and what are we gonna do? We're gonna have two node stars. One's gonna be temp, and we're gonna equal to star L. So we're just taking, we're having temp, and we're gonna have that equal to L. We're gonna have that. So whatever L is right now, it's gonna take the front of the list and put it into temp, and we have the front of the list now in temp. So we're gonna have another one called node star temp2, and we've done that equal to nothing, and we're gonna have a while loop to traverse the list again, and we're gonna have to have it equal or not equal to null. If it does, it breaks out a loop and it's done. Alright, and we're gonna continue on. We're gonna say temp2 equals temp follow next. So we're just gonna be holding the next node in the list. So the list doesn't not lose its link. So the reason I'm doing this is so when I free temp, it's gonna lose the temp next. You're not gonna be able to get that. So we have to save it before we free temp, which we're gonna do right now. So we're gonna say free temp, and once we do this, we can't do temp next anymore. That is until we do temp equal temp2, and now temp is equal to temp next originally. Alright, so now we got the first, every time we run this through this while loop, it keeps freeing up the memory in each node until we reach null, or the end of the list. And we're gonna have star L is equal to temp, which is an empty list, and we're all done. And now we can just test it out by writing an int main down here, int main, and we're gonna do int user num, and then we're gonna have a node star L is equal to, or actually, we don't have a return on that. List init, and it's gonna be L node star L, and we have to have an ampersand here just because it's a double star that it takes in, right? I believe so. Yes, it is. All right. So now that we have that all set, we still we're gonna go ahead and read the numbers from the user and go ahead and push them onto the linked list. So the way we're gonna do that is I'm just gonna do a scanf here. I'm gonna say scanf %d quotations %d space, and then we're having an ampersand. That's how scanf works. And we have a while. I'm gonna say while user num does not equal -1. Just because I don't want to make a parser right now. I don't want to do all that crazy stuff. I just want to put -1 and it ends the read-in. And I'm going to say lists push. And I believe our first value it takes in is a node's double star. So I'm going to do an ampersand L. And I'll push in the user num. End that. And then I'm going to do that's another scanf, the same one we got up there. %d space, %d space. Then we'll put user num, and then this thing continue this loop until it hits -1, until the user puts in a -1. Then what we're gonna want to do is just print a list just for demonstration purposes. So list print, and I can just send it L, and then I'm gonna do a list free. You know, things are double, so I could do an ampersand L. So this is gonna free the list down here. This initializes it, so we know what null is. Alright, this should work when I press. Oh, what did I do wrong? Oh, we don't need this actually. I'm sorry. That's if I were to have I'm sorry, malloc the first element. But it's a null. I made a mistake there. You don't need those. Everything should work fine. Undefined to list print. Oh, oops, misspelled that. List print should work now. Looks like it does. Let me go ahead and type in some numbers. What just happened? Let's see. What just happened? Oh, let's see. Let's push. List push. Temp malloc, yes. And temp val and temp next equals star L and star L equals temp. Let's print. That shouldn't have any effect. Oh, that's the problem right there. I always make that mistake. Let's scan that. I forget the ampersand. Alright, we're all set. So takes the numbers, put a -1 in. There you go. And we're all set. So as you can see, it reads it from 234, which is the last number put in, all the way to the first, to 34. In our brackets, if you have any questions, please leave them down in the comments below. If you like my video, please give it a like and subscribe. It helps out the channel. And that's it, guys. If you have any suggestions, please leave it down below. What do you want to see next? If you want to see a binary search tree, if you want to see just a binary tree, if you want to see graphs, or if you want to see, I don't know, anything, just link it down below, and I'll try my best to get it out there for you guys.